Take a look. It's a rapid chemical reaction that's releasing make that huge amounts of light, heat, and smoke. It's hot. It's fire!
Learning safety, smart science. Right now, safety, smart science. Be safety smart. It's time to start. Learning it now with Bill Nye.
Fire! Safety Smart Science is brought to you by Smoke Alarms. We don't mean to alarm you. Actually, we do.
Fire. It can be destructive, burning down buildings and entire forests. And it can be useful, providing warmth when it's cold, light when it's dark, and heat for cooking our food. No thanks. I prefer mine burnt. Here at Underwriters Laboratories, fire safety engineers make sure things are up to fire safety standards. Things like appliances, furniture, even entire houses. Now, how do they do that, you ask? What say you ask? They do that by burning things in controlled, safe environments. See, when you understand the science of fire, you can be safety smart. Around here, the motto is fire is servant, not master. That means you control fire. Fire doesn't control you. If you understand the science of fire, controlling it's not that tough. Fire needs three things to keep it burning: heat, oxygen, and fuel. Fire can become a real monster, destroying everything in its path. So to fight or control a fire, we control the amount of heat, oxygen, and fuel. We've got some nice fires. They're big and hot. Now what's happening is that wood is a fuel. It turns to a gas and combines with oxygen in the air in a chemical reaction that releases light and heat. It's a fire. Now, how do we control a fire like this? Well, here's one way. You see, the water takes heat away from the fire so fast that the chemical reaction can't keep going, and the fire goes out. Works every time. This is the oldest trick in the book. Cave people must have put out fires like this. Now, here's another way we can control fire. If you've got something that doesn't burn, you can cover it. And look, the fire goes out in just a few moments because it can't get any air, which has oxygen. So the chemical reaction can't keep going. And this fire goes out. Now, since we have three fires, you might be able to figure out that there's a third way to control a fire. And that's like this. See, when we spread the fuel away from the heat, the fire goes out. So whether we take away the heat, take away the oxygen, or take away the fuel, we can control a fire. Know the science of fire. That way you can be safety smart. It's cool. I mean, whew, it's hot. This is the fire triangle of science. Now in the middle is a chemical reaction, combustion, fire. But if we take away any one of these three things, take away the heat, take away the oxygen, or take away the fuel, the fire goes out. By understanding the fire triangle, we can control fire instead of it controlling us. And that way we can use it for useful things, like cooking our food or just keeping warm.
Breaking news from Chicago. Stuff burns. Let's go to the tape. Safety engineers test all kinds of stuff to be sure it meets safety standards. I sent a chunk of foam from my producer's chair to see how it rates. Let's take a look. The chunk of polyurethane foam caught fire right away, continued to burn, and actually turned into a flaming liquid mess. The point is this. Things you wouldn't normally think could catch on fire do. Like this peanut. Burns like a candle. Wicked!
Take a look at these. There are hot dog cooking ovens of science. Now in this first oven, we have a hot fire, and it's cooking these hot dogs. And the reason the hot dogs are cooking is because they're touching this hot metal plate. Heat is moving from the hot plate right into the hot dogs. And when heat moves this way, we say heat is moving by conduction. Heat is conducting from the metal plate into the dogs. In a building fire, one example of conduction is when a hot door heats up a room, even though you can't see the actual fire behind it, and transfers the heat into the room. Conduction can heat things up real fast. Take a look at this. This hot dog is cooking, but not because of the metal rod. The metal rod is barely warm to the touch. Instead, this hot dog is cooking because heat is moving from this lamp right through the air, just the way rays of light move through the air. We say the heat is moving by radiation. The heat is radiating from the lamp onto the dog, and it's cooking. The power of radiated heat can be seen in a flashover. A flashover is when hot smoke radiates heat and causes the surfaces in a room to heat up to a point where they release flammable gases. When the temperatures get hot enough, around 1,000 degrees Fahrenheit, these gases react with oxygen in the air and ignite. At that point, anything that can catch on fire does. Stuff just bursts into flame. Now that's one hot chemical reaction. Now this hot dog is cooking too, because it's right above these hot wires. But it's cooking faster than the one that's being cooked by radiation because of the warm air that's moving around it. Watch this. We're filling this oven with fog. That ought to do it. Thanks, guys. Now watch what happens when we turn on the heat. See how the fog went right up? That's because the hot wires make the air around them hot, and the air spreads out. Then the cool air in the room squeezes that warm air up, right past the hot dog. This is heating by convection. The air is convecting onto the hot dog, carrying the heat. Now in some places, in some ovens, we speed up convection with a fan. Then a hot dog cooks really fast. Oh man, listen, I gotta get something to eat. During a fire, rising hot air continually draws cooler air to the base of the blaze. That's convection in action. The hot air makes things pretty toasty up top. So because heat and smoke rise, if you're ever in a fire, remember, get down where the cooler air is and get out. Oh, conduction, radiation, convection. Knowing how to control the transfer of heat helps you be tasty smart. I mean safety smart.
This Safety Smart Science dramatization is brought to you by Stuff That Burns. Liquid, solid, or gas, don't fuel around.
This looks like an ordinary room, and it is. And like any ordinary room, it's full of things that can become fuel. There's natural fuels like this wood, and synthetic fuels like this microfiber couch. Now, the fire can't sustain without fuel. I mean, that's the fire triangle. But even these plastic cups, this pitcher, can become fuel if there's enough oxygen and heat. Now, all of these different fuels will turn to a gas before they burn. This is a gas stove. The fuel is a gas, and it makes a flame. If we open this valve, the flame gets bigger. Now, if we turn it off, so there's no more gas, well, the flame goes out because there's no more fuel. So on this stove, the fuel is a gas. This is an oil lamp. The fuel is this liquid oil. It works its way up the wick to the flame. Now the heat of the flame is making the liquid change to a gas. Now that makes more heat and makes more liquid change into more gas. It's a chemical reaction that will keep going as long as there's fuel. Wow. These are wood chips. Now watch what happens when we heat them up. The wood is not burning, so the heat is making the wood change from a solid into a gas. And it's the gas that burns. Now, whether the fuel starts out as a gas, starts out as a liquid, or starts out as a solid, what ends up burning is always a gas. Isn't that wild?
Truth is stranger than fiction.
The flame of a candle in space has a different shape than on Earth. But why? Earth's gravity gives our atmosphere density. On Earth, hot gases coming off of a candle flame are lighter than the air around them, so they rise, pulling the flame into a teardrop shape. But in space, like on a spaceship, the hot gases spread out evenly in every direction, so the flame is in the shape of a ball. And that's just one more reason that
Truth is stranger than fiction.
On our last program, you might recall, we had a little problem with a grease fire. Jan is here to help demonstrate the safety smart way to put out a grease fire. Oh, there she goes. Jan, what are you going to do about this?
Well, first remove the heat by turning off the stove. Then cut off the oxygen with the lid. That will control the fire. If you have baking soda or salt, you can smother it with that too. But never use flour. It burns.
That would have been good to know.
What's really important is most fires can be cooled with water. Not so with the grease fire. You combine water and hot grease, it turns into steam that explodes.
Thanks, Jan. That's good to know. And that's safety smart. Now, let's say you're making popcorn with your microwave, and you accidentally hit 30 minutes. Well, it'll overcook and most probably catch on fire. Oh boy, we've got a fire. Now, the safety smart thing to do is turn the microwave off and keep the door shut. Microwaves have an airtight door, so the fire will burn out when it uses up all the oxygen trapped inside.
Be safety smart. Have a fire extinguisher on hand and know how to use it.
You can't survive very long in a room without oxygen. See, we need oxygen to live too. That's why oxygen is part of the fire triangle. Using a device like this, fire safety scientists can precisely control the amount of oxygen in this tube. Now, different materials need different amounts of oxygen to keep burning because fire is a chemical reaction. So by increasing the amount of oxygen, the flame will get bigger. But if we take the oxygen away, the flame will go out. See? It's a chemical reaction. Fire safety. It's science.
On the average, there's about 125 products in your home that UL has evaluated for safety. We look at different aspects of fire, how things burn, how we put them out, how we contain it, and how we protect it. This product alone has been subjected to over 21 separate tests. We study everything about the fire extinguisher. It's not just one test. It's the strength of the container, the gauge, the stuff that's inside of this. All of that is important for making this a safety product that we use all over the world. Sometimes in the order of 4 or 5 minutes, you can go from a tiny little candle flame to having your entire living room engulfed in flames. The things in your home really are fuel. This is made of synthetic materials. At the end of the day, these things will burn, and so the way that you detect that fire most rapidly is with a smoke alarm. 24 hours a day, you need smoke alarms and you need carbon monoxide detectors. It's there to protect you when you're sleeping, when you're doing your normal daily activities. What's really important about a fire extinguisher, and this is where education comes in, is that the fire extinguisher is your line of defense to get you out of the home. We have to make sure that when fire extinguishers are used, they are not used to stay in the house to put the fire out. The fire extinguisher is absolutely there to help you clear a path to get out of your home.
What's going on here? Well, fire safety engineers test things like this in a controlled burn all the time. By understanding the science of fire, you can keep your family safe. How did a big fire like this get started anyway? Candles are a common cause of devastating home fires. This is what happens when you leave a silly little candle unattended. Wow, fire is fast. That little candle was turning into a pretty big blaze. In less than 30 seconds, a fire like this can be completely out of control. And fire is hot. You can feel the heat from that thing way over here. Now see that stripe on the wall? We've mounted temperature sensors from the floor to the ceiling. And even in the fire, they'll still give us readouts. We can see the temperatures on these displays right here. As we go from the floor to the ceiling, you can see that it's getting hotter and hotter. Up here, it's over 150 degrees. See, what's happening is the flames are making the air right above them get warm and expand. And then the cool air around them is forcing that warm air up. That's convection. And it's bringing fresh oxygen to the fire all the time. So it just keeps getting hotter and hotter. And it's making the walls and the ceiling of that room pretty hot as well. Smoke kills more people than flames do. Smoke is lighter than air, so it fills the room from the top down. Way before you see smoke like that, it's time to get down and get out. You see, the fire is making the room hotter and hotter. All of the fuel in there, the tables, the sofas, the books, the toys, everything, are turning into a gas. And that gas burns just like that. It's like spontaneous combustion. It's what we call flashover. And when that happens, you don't want to be in there. Well, you can't be. But when a fire breaks out, having a working smoke alarm and carbon monoxide alarm dramatically increases your chances of surviving a fire. Smoke and carbon monoxide alarms should be installed on every level of your home, especially near sleeping areas. Install home sprinklers. Keep a fire extinguisher on hand. Develop a home fire escape plan with a meeting place outside. Make sure everyone in the family knows 2 ways to escape from every room. Now, all of this could have been prevented like this. Never leave a candle unattended. Know the science and be safety smart. Makes you want to relax, doesn't it?
Truth is stranger than fiction.
Oil well fires are extremely difficult to put out. They have a huge amount of fuel that feeds them, and they create an amazing amount of heat. One way to put out an oil fire is with dynamite. When the charge is set just right, the explosion robs the fire of oxygen and blasts the fuel and remaining oxygen away from the heat of the flame. No oxygen, no fuel, no fire.
Truth is stranger than fiction.
Welcome back to Who's Hot? Now, before we wrap up, I'm going to ask my guest the hottest question yet. Mr. Flame, just exactly how do you come into being?
You're talking about spontaneous combustion?
Too personal?
No, I have no problem sharing that with you, as long as you don't use it against me.
I wouldn't do that.
For me to burst into flame, I need heat, and that heat needs some fuel to heat up. With solids and liquids, heat unlocks flammable gases. Finally, the gases react with oxygen to create a chemical reaction. Whoosh! You get me.
So you need heat, fuel, and oxygen to survive.
That's right. So
So if we took away any one of those three, you would be...
I don't like where this is going.
extinguished?
Well, tell the whole world, why don't you?
Woo! Simmer down, Flame Boy! Woo! That's it for today. Tune in next time to Who's Hot? Bring it down there. Fuego.
I know the safety smart science about fire. I can make it go out or go higher. Fuel, heat, and oxygen, a triangle of fire. Remove any one of them, the flame will expire. Cool the heat with water, take away the fuel. Smother out the air, there's no exception to the rule. I know the safety smart science about fire. Yes, I do now. I can make it go out or go higher. Energy from heat moves in every direction. It rises in the air through the act of convection. Conduction moves heat through many obstructions. Light a lamp to see moving waves of radiation. I know the safety smart science about fire. I do too now. I can make it go out or go higher. Get down. Get out! Flash over! When a room is burning up, it fills with smoke. A smoke alarm can warn you before you start to choke. Know the science about fire, you can be its master. To make light and power and avoid a disaster. I know the safety smart science about fire. Do you? I do. Me too. I can make it go out or go higher. Get down, get out. We know the safety smart science about fire. Yes, we do now. We can make it go out or go higher.
Being safety smart with fire can be, well, delicious. Get some graham crackers, some chocolate, and a perfectly toasted marshmallow, and you've got s'mores. Now, you know when you're done with your fire, you've got to put it out. So you can take away the fuel by breaking it up. You can take away the oxygen by covering it. Or you can take away the heat with some nice cool water. See, that's the fire triangle. When you stop the chemical reaction, the fire goes out. Fire is servant, not master. But if a fire does get out of control, you know what to do. Get down, get out, and then call for help. See, when you understand the science of fire, you can be safety smart. Oh, I gotta go.